6.4 Parallel and Perpendicular Lines. What we're looking at here is how parallel and perpendicular lines relate to slope. Parallel lines are basically lines that run in the same direction. They run in the same direction and they never cross. So there's an example of two parallel lines. They're running in the same direction. They never cross. We use these little chevrons to indicate that the lines are parallel. So if we were to, for example, let's just look at an idea of a parallelogram. If I was to draw a parallelogram, in order to draw a parallelogram, what you need to do is indicate that this is a parallelogram by drawing chevrons on the lines indicating that they are parallel to each other. Okay, on that note, the equations of parallel lines have special features. One of the most important things is that parallel lines always have the same slope. So their equations will always have the exact same slope. Perpendicular lines are basically lines that cross each other or intersect each other at a right angle at 90 degrees. So here's an example of two perpendicular lines, and you would indicate that they're perpendicular by putting a little box in the corner, indicating that the lines intersect at exactly 90 degrees. Now, the special feature about the equations of perpendicular lines is that their slopes always are negative reciprocals of each other. That is, when you think about it, you have a slope of one and the slope of the other. If I was to multiply the two slopes, I would end up having an answer always equal to -1. So that's a neat little feature of negative reciprocal slopes. Another way to think about it is by looking at the actual words. Negative reciprocal means that we change the signs of both of them. So if one was positive, the other one would be negative. And reciprocal means that one is the flip of the other. So we will look at examples that will refer to parallel and perpendicular lines. Example 1. Which system has parallel lines? And which system has perpendicular lines? And justify your answer. So, looking at the first two equations, what do you notice? And then looking at the next two sets of equations, what do you notice? Well, first thing we have to do is look at what? That's right, their slopes. The slopes of the two lines. So I take the first line, we'll call that line 1. We take the first line, we call that line 1. Take the second line and call it line 2. And what we will have now is we're going to look at the slopes of these lines that are in a system. That is, we look at slope 1 and we find out that the slope of 1 is 2/3. Then we take the slope of the second one and we find out that slope is -3/2. So now what we need to do is look at the slopes. Are they equal? Nope. But if I take the slope of 1 and I multiply it by the slope of the second one, we find out that the answer to that is, let's multiply them. Well, we'll have 2 times -3, which is -6, over 3 times 2, which is 6, and -6/6 is equal to -1. That is, when I multiply the two slopes, that equals -1. Where have we seen that before? Well, you should remember that if you take the two slopes and you multiply them, they equal -1. That means the slopes are the system is perpendicular. And that is because the slopes are negative reciprocals. Now, let's look at the actual equations of the slopes. Let's look at this. Notice here, This is 2 over 3. So in the equation, this is y equals mx plus b. We look at m, which is 2 over 3. We look at the other m, which is negative 3 over 2, and we see that they are the flip of each other and their opposite signs, which is the definition of negative reciprocals. And because the slopes are negative reciprocals, we can say that the system has perpendicular lines, or that the system is perpendicular. The two lines cross at a 90-degree angle. Moving on to the next one. Looking at these two equations. Well, these two equations are not in y equals mx plus b form. So what we have to do, label them 1 and 2, we have to be able to identify what the slope is in this system. That is, we need to find the equation in y equals mx plus b form, which we've already done in a previous section. So, to do that, we convert number 2 to slope-intercept form. That is, we take 2x plus 15 equals 3y. What we did, we moved 3y, the minus 3y, over to the other side to make y positive. That's the first rule to convert to slope-intercept form. Isolate for y where y is positive. Next step we're going to do is divide each term by the coefficient of y. So we want to make y by itself. So we're going to divide each term by 3. What do we end up with? Well, we end up with y equals, what's the equation? 2 over 3x plus 5. What does that tell us? Well, looking back up here, we have that's our equation 2. Our slope of 1 is 2/3. Our slope of 2 is, well, we found out over here that our slope of 2 is also 2/3. And because of that, we found out that m1 is actually equal to m2. What does that tell us about the system? Well, that means that the system is parallel, and that is because the slopes are actually equal to each other. They're the same. m1 equals m2. Okay, moving on. Example 2. The equation of a line is 5x minus 10y plus 2 equals 0. What is the slope of a line that is parallel to this line? So, what is the slope of a line that is parallel to this line? Well, first of all, we need to know what does parallel mean. And if you remember correctly, parallel means that the two lines would share the same slope. So if we find the slope of this line, that means we find the line that's parallel, that slope as well. And that's what the question is asking. So we're going to convert to slope-intercept form the equation 5x minus 10y plus 2 equals 0. That is, what we're going to do is move the minus 10y to the other side. We get 5x plus 2 equals 10y. Why do we do that? Well, the y is negative here. We move it over to make it positive. And then the next step is to divide each term by 10. Each term by 10, and we end up with, that's right, y equals 1/2, because 5 over 10 is equal to 1/2 x, plus 2 over 10, which is 1/5, equals y. That's our equation. Y equals 1/2 x plus 1/5. What's the slope from here? Well, the slope from here is equal to 1/2. What's our parallel slope? Well, our parallel slope is going to be the same slope. So our parallel slope will be 1/2. If m equals 1/2, that means our parallel m will also equal 1/2. Okay. And that's all we have to do for this question. Moving on. Example 3. Given a line y equals 3/4 x minus 1, what is the slope of a line perpendicular to this line? So what are we looking for here? Well, we're looking now for a perpendicular slope to this line. Let's look at the equation. This equation is in slope-intercept form. What is the slope? Well, m equals 3/4. What's our perpendicular slope? Well, that is, now be careful, we need to take the negative reciprocal of this slope. So negative reciprocal. Right now it's positive. We want negative. Next step we need to do is do the reciprocal. Reciprocal means flip. Flip the fraction. So it becomes negative 4/3. So our perpendicular slope will be m equals negative 4/3. Example number 4. Fill in the table. So we have a table here, folks. We're going to have an equation, and we want to find the perpendicular slope and the parallel slope. So here are a bunch of equations. Let's say I have a line that has y equals negative 3/2x minus 1. What will our perpendicular slope look like? Well, I know my slope is negative 3/2. Our perpendicular slope, so if we identify it as perpendicular m, is going to equal, that's right, positive 2/3. Remember that the slope here is negative. We take the opposite sign and we flip this. So it's positive 2/3. Our parallel slope, our parallel m, will end up being what? Well, that will be the original slope, which is negative 3/2. Okay, let's try another example like that. 5x plus 15y minus 1 equals 0. That's the equation you're given. Find the perpendicular slope to that. Well, folks, what we need to do is isolate for y first. That is, we need to take 15y, leave it where it is, okay? And we have to find out 15y equals what? Well, it equals, move the 5x over, it becomes negative 5x. Move the minus 1 over, it becomes plus 1. And what we now do is we're going to divide each term by 15. And we end up with y equals negative 1/3 x plus 1/15. Well, what will our perpendicular slope look like? Well, our perpendicular slope will look like the following. Ready? So again, I just put it up at the top here so you guys could see this, just in case it's hard to read inside the table. I rewrote it up here, 5x plus 15y minus 1 equals 0. 15y equals negative 5x plus 1. Divide each piece by 15, and we end up with y equals, oops, let's pause that, folks. Here we go. So we have 15y over 15 minus 5x over equals negative 5x over 15 plus 1/15. And what we're going to do is simplify to get y equals negative 1/3 x plus 1/15. So there's just a larger version of what you see inside the table, because that's what you would have to do first. Now, we need to identify the parallel and the perpendicular slope. Let's do parallel slope this time, folks. What's the parallel slope? Well, the parallel slope is going to equal negative 1/3. It's the same slope as the original equation. And our perpendicular slope will end up being, well, our perpendicular slope will end up being the flip and the opposite sign. Opposite sign means it'll be positive, and it will be positive 3, because 1/3 flipped is just 3. Okay, let's try another equation. Y equals 2x minus 5. The easiest one to do is obviously the parallel slope. Parallel slope is the same slope as the original, which is 2. Now we want the perpendicular slope. The perpendicular slope will be equal to negative, flip, so opposite sign, and flip of 2 is negative 1 over 2. Finally, our last one, 8x minus 2y equals 0. Well, first thing we have to do, folks, is isolate for y. So let's do that on the side here. We're going to isolate for y. And you would have 8x minus 2 equals 2y in order to make y positive. And we divide both sides by 2. And we end up with y is equal to 4x. So this would be a direct variation if we were talking about variation, because the y-intercept would be 0. So y equals 4x is an equation of a line. Now what we have to do is identify the different slopes. Our parallel slope will be parallel m will equal 4. And then our perpendicular m will be negative 1 over 4. So opposite sign and flipped. Okay, moving on to another example. Example 5. A triangle has vertices A, B, and C. In order to determine an example so part A says, is this a right triangle? And justify your answer. So we're not going to draw it, folks. All you're asked is this type of question. So when you think about it, this type of question would be something that would be an inquiry type question, where you have to justify your answer and you're asked to determine if a triangle is right angle or not. How would we do that? What do we need to do? Some people would like to graph this. It's not always feasible for you to graph certain concepts like this. This one you could try and sketch it, but it would be not enough to be able to prove that it is a right angle or not, even if you use the protractor. So what we need to do is prove this mathematically beyond a reasonable doubt. And that is, we need to find the slopes of each side. If we found the slopes of each side, 2 of them should have a special connection. If you find the 2 that have the special connection right away, well, then we're done, folks, because that's enough to prove that it's a right triangle. So, if we find the slope of AB, so slope of AB is equal to A, write the point upwards, 1, 2, B, write the point upwards, which is 3, 8, and then now we run with 3 lines, 1, 2, 3. And now what do we get? Well, we would get negative 6 on the top, negative 2 on the bottom, which results in the value of 3. Next, we find the next slope, let's say BC. Well, the slope of BC is equal to, B is 3, 8, C is 6, 7, and we draw 3 lines. What will that result in? Well, negative 1 on top and negative 3 on the bottom. If you look really carefully, folks, right away, we found our match that we're looking for. We can see that the slope of AB times the slope of BC is going to equal negative 1. That is, the slope of AB is negative reciprocal of slope of BC. That means, that's right, folks, that triangle ABC is actually a right triangle because AB is perpendicular to BC. Remember that the upside down T represents perpendicular in mathematical language. Okay, let's try another example. This time you try it. Same type of question, okay, given triangle PQR with coordinates P, Q, and R, you're asked to determine if PQR is a right triangle and justify your answer. So this is all you're given. What I want you to do is take a moment and be able to answer this question before I reveal the answer. So again, stop the video now. Okay, hello, we're back. So, what did you do to be able to solve this? You should have taken the slope of each of the sides like we did in the previous question. That is, take the slope of PQ, which is 4, 8, and negative 4, 4, draw 3 lines, and we end up with 4 over 8, which results in 1 over 2. Next part is we're to find the slope of QR. That is negative 4, 4, 10, negative 4, and draw 3 lines, and we should get 8 over negative 14, which results in negative 4 over 7. The slope of PR is equal to 4, 8, and 10, negative 4. 1, 2, 3 results in an answer of 12 over negative 6, which results in an answer of negative 2. Looking at these answers, do you see what I see? Well, I hope so, and that is that 1/2 and negative 2 have a special connection. That's right. PQ and PR turn out to be perpendicular. That is because if I take the slope of PQ and I multiply it by PR, that will give us negative 1. So they are negative reciprocals of each other. PQ is perpendicular to PR, and therefore we can say that triangle PQR is a right triangle. All right, folks, well, that's the end of the lesson. Have a numerical day.